Okay, so take two. So these video notes are on solving cubic equations. So there's going to be multiple methods for solving these equations. You're going to have to be able to look at the equation and try to figure out what to do. So this first equation right here, first of all, notice it's cubic, okay, which means it's going to have three solutions, possibly real, possibly not real. And these real solutions are going to be located on the x-axis. And that's why we set the equation equal to 0. We made our y value 0. So anyway, let's go ahead, and what you should notice right here is you can factor an x out of each term. Okay, and so from here, we have one factor here, x, and we can set that equal to 0. And then we would use the x factor on this and get the other two solutions from there. So that's one type of problem you might encounter. Second type of problem, it's kind of similar to the first. But so we're factoring out, we see an x in common, so we'll factor out the x. And then from here, I just wanted to show you and remind you that when you have a difference of two perfect squares, you can just very easily factor that to x minus 2 and x plus 2. You can do the x factor on this, but it would be a lot easier if you could recognize the difference of two squares. And then solve those for x. Notice 3 solutions. 3 factors, 3 solutions. Okay, another type of problem. This one's kind of a straightforward problem where there is a leading term and then you have your constant with no x squared or x in the middle. So in this case, we can just very easily just solve for x the normal way, undo subtraction with addition. And then undo the 4/5. The easy way would be to multiply by 5/4 on both sides. That would take care of the fraction altogether. So we're multiplying by the reciprocal on both sides. And then you would want to undo a cube with the cube root on both sides. So the cube root cancels out the cube. So we're going to end up with x equals the cube root of 15. And since 15 is not a perfect cube, we're just going to have to leave it like that. The cube root of 15, which would end up being decimals. These would be irrational solutions since they're decimals. Okay, moving on. Let's take a look at another example you may encounter. Let's see, we're number 4. So in this case, you can't factor out an x out of each term, right? And we have some x's in the middle, so we can't just solve it the traditional way where we add 1. So in this case, we have to notice that these two in the front, we could factor out an x squared out of both of these terms. Right? And there's nothing we can factor out of those, so we'll just bring that group down. Actually, what I'm going to do is I'm going to factor out a 1, which basically keeps it the same. And remember, this is called factoring by grouping. Always got to keep an eye out for that too. So we have x squared plus 1 and 2x minus 1. And then we have to solve these. So set each factor equal to 0. And yes, I'm going fast. This is review. And solving this the traditional way, we're going to subtract 1 on both sides, square root both sides. So guess what we have right here? We have plus or minus I. So there's two imaginary or non-real solutions. And then over here, if we solve for x, we end up with 1/2. So in this case, we're going to have a real solution and an imaginary solution. So what might this look like on a graph? Well, let me show you real quick. So this one is going to probably cross at a half. So it's probably going to go, it's going to look something, I should put it in my calculator. Give me 1 second. So notice we have the root at a half. That's our real solution. And it doesn't cross the x-axis anywhere else because the other two roots are imaginary. Okay, now this last one is a biggie because it's new. So you're going to really want to pay attention on this part right here. So we're going to have number 5. So here is our equation. You could try to factor this by grouping, but I don't believe it's going to work. So we can't factor out an x out of each term. We can't subtract the 4 and do it the traditional way. So we're kind of stumped. Like, how are we going to solve this? Remember, to solve this, we're trying to find out what x equals. We're trying to find the roots. So there is a rational root theorem that we can use on this. And the rational root theorem is going to give us all possible roots, aka solutions. And so if we know one of the solutions, then we can use what's called synthetic division, and you'll see what I mean shortly. So to get all the possible rational roots, what we do is, in textbooks, they call this value on the end the constant p and the leading coefficient q. So what you do is you write down all the factors of p. So 24. How did we end up with that awesome number? 1 plus or minus 1 plus or minus 2 plus or minus 3, 4, 6, 8. All these numbers go into 24 evenly. And 1 and 24, 2 and 12, 3 and 8, I got that one already, and 4 and 6. I think I got them all. So those are all the possible factors of 24. Q. Oh, that one's an easy one. Q is 1. So that's just going to be plus or minus 1. Oops, plus or minus 1. Now, once you've done all that, here are all the possible. Now remember, possible doesn't mean that they're all roots. These are all the possible roots. You put P over Q. So 1 over 1, that would be 1. 2 over 1, well, that would be 2. 3 over 1, well, that would be 3. And so on. And so on. So what we do next is we use synthetic division to see which of these are solutions to this. So to do synthetic division, we write the coefficients. So the x cubed has a 1. The x squared is -3. The x is -10. 24 is the last one. Okay, then we draw a line down and over. And now we start testing these. So since I already know what one of the solutions are, we're going to go straight to it. We're going to use +2 as one of the solutions. You would have to test them to find out which one's going to work. So +2. So +2 is going to go over here. We're going to divide by 2. So we bring down the 1. 2 times 1 is 2. So we're multiplying that way, timesing. And then we add straight down. -3 plus 2 is 1. Then we multiply. We get -2. And then we add straight down. -12. And then we multiply. And we get -24. And then we add. And that's the remainder. So, because the remainder is 0, we have found one of the roots, aka solutions, to this cubic equation. So we know that one of the answers is x equals 2. Now, what you do next is, once you find one, you don't have to continue. You could continue using synthetic division and do the same process using these other numbers, but it would be easier now to just rewrite this as an equation and solve it. So this was cubic. Once we took out one of the roots, it changed to quadratic. So we have 1 x squared minus 1x minus 12. So this creates the next equation. And then all we have to do is factor it. Or if factoring doesn't work, it might be imaginary, which would mean you would have to use the quadratic formula. So factoring this, we're going to get putting those on top. So we're going to have x minus 4, x plus 3, solutions. My other two solutions are 4 and -3. And then back up here, we found out that that was one of the solutions as well. So, in some cases, when you can't do anything, we use the rational root theorem. Find all the factors of p. That's your number on the end, your constant. Your q, factor your q. And then you put all the p factors over the q factors. You may be asking, why positive and negative? Because remember, the p value is 24. So 1 times 24 is 24, but so is -1 times -24 is also 24. These will always be plus and minus on those factors. And then we start, I'm very systematic, I would start with 1 and do synthetic division. If it didn't work, if it doesn't work, your remainder will be something other than 0. If it didn't work, I'd cross it out, try -1. You can skip around, but make sure you cross them out after you try them. You just need to find one of them that works, because then you can take this and write the equation and solve it.